All right, I want to welcome everyone to Heat Pump Water Heaters Installs, Sales, and 101. Before we get started, I want to say a big thanks to our top tier sponsor for this session, Build Equinox, featuring the Serve 2. This device is an all-in-one heating and cooling and ventilation filtration system with humidity control. Smart ventilation with energy recovery ventilator is ultimately the future. Think we're going to have lungs in our home that are smart. We all will. This potential device detects poor air quality in the home and then ramps up to remove it as needed, but then runs real low, saving energy, but still ensuring good air quality. The Serve 2 features energy recovery ventilator, so fresh air is brought in, but does not have to waste energy, and has a built-in heat pump to ensure that incoming air is not too hot or not too cold. All units are made right in Urbana, Illinois, 100% solar-powered, locally owned factory right here in America. You can check them out and all their amazing and fun blogs that they put out at buildequinox.com. And we also want to thank our second tier sponsors, Water Furnace and Enertech. Geothermal and ground source heat pumps cool as well as heat water in the most heat water and cool in the most energy efficient way possible on the earth. Forced air radiant for small projects or large buildings or communities. And now with the Inflation Reduction Act, you're going to see a 30% tax credit through 2030 using this super efficient technology. So check it out at Water Furnace and Enertech. Again, welcome to Heat Pump Water Heaters Installation, Sales, and 101. Just as a reminder, we are the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the places we live. Today, I will be your moderator. My name's Brett Little. I'm the education manager here. And just as a reminder, this course is approved for multiple continuing education units, as well as AIA, Health, Welfare, and Safety. Sorry, I missed the screenshot of that. And under our Certified Green Home Professional Designation, Energy and Health. So I'm going to stop talking here and hand it over to our speaker today, which I really appreciate him taking time to catch us up on this important technology. Greg Holliday, he is the Business Development Manager and Specialty Markets for Bradford White Water Heaters. And so Greg, welcome, and please take it away.
Thank you very much, Brett. Good to be with you guys today. Let me pull up my screen here so we can get things going. Welcome to my farm in Kentucky. You're now on 22 and a half acres just outside of Louisville, where my wife and I have 40 years lived, with a few horses outside, a few deer. For those of you that live in deer country, we just came out of deer season, and here I am going to teach you about heat pump water heaters today and why this product is such an important product to have in this industry. And that simply is because these are the only water heaters that truly make sense. I've spent the last 32 years working for General Electric, where I had the privilege of introducing the first ever Energy Star approved heat pump water heater way back in 2009. So I've got probably the longest history in the industry right now with this one product. We private labeled this product for Bradford White. And at some point, Bradford White decided about 6 years ago to hire me away from GE, and then bought the GE plant in Louisville, Kentucky, and moved it to Middleville, Michigan, not too far from where you guys are. So I give you all of that so that you kind of know that my background is steeped in heat pump water heaters. I believed enough in this technology that I wanted to stay with it, and chose to go with a water heater manufacturer to continue to make that happen. So as we go through this, I'm going to teach you everything you essentially need to know about heat pump water heaters. You're going to become an expert pretty quick. You're going to be able to answer more questions for folks around you than anybody else, because you've listened to 1 hour of hearing not just how these things work, but the whole history of the industry and how this thing even got started. So I want to keep this in perspective, and I want you to be able to look at the big picture, because the big picture is the really important view here. When you look at the big picture of water heating as an industry, all water heaters that have ever been produced lose money every time they turn on, because they're all less than 100% efficient. Now, that's something we are willing to accept with lots of products that we have at our house. A typical electric water heater is about 93% efficient. A typical gas tank water heater about 60 to 67%. A typical gas water heater 82 to 97%. But heat pump water heaters, when you look at that big picture, are over 300% efficient, and some hitting 400. What does that mean? That means that for every $1 you spend to heat water, you're getting somewhere between $3 and $4 in actual hot water. I want that to sink in for a second, because you're hearing a lot of things about decarbonization and electrification and all of the things that point to green technologies. And I want you to know something about this. This is a green technology, but it's also a practical common sense technology that says if I've got an electric water heater in my house today and it's losing 7 cents of every dollar I spend to heat water, I want to change that to a water heater that's going to give me between $3 and $4 in hot water for every $1 I spend. I'm going to make a business decision that says I'm going to put $300 to $400 a year in my pocket rather than giving it to the utility. And if I do that as a homeowner, I make a good business decision for my house. And that's the perspective I want you to think of. Now, the end result is that it does produce less carbon because it doesn't produce any in and of itself. It's just what is generated by the power company. So it's the right green choice to have, but it's also the right financial decision to make for your house. So what does this do for builders? It gives them a house that looks better, performs better, uses far less energy than a standard construction home. For a HERS rater, it helps them provide somewhere between 4 and 6 HERS points, 3 to 4 LEEDS points, because this is not just higher efficiency, it's the highest efficiency that you can have. So keep that big picture perspective as we go through. So we're going to talk about a little more about why they're so significant to the US market, how these products work using the same principles of refrigeration. Moving heat is cheaper and easier than creating heat. I want you to write that phrase down because that is the key to understanding heat pump water heaters. We're going to talk about proper site selection because where they go in the house does make a difference as to how they perform. They'll always outperform a standard electric water heater. They'll always outperform in energy usage a gas water heater of any kind. But when you put them in the better places, they perform even better. We're going to talk about service requirements. What's different about installing a heat pump water heater? Well, the most important thing is space. So you architects that are out there understanding that you need about 7 inches around a heat pump water heater to be able to get air circulation. We're going to talk about that. And we're going to talk about condensate drains that are the only significant difference when it comes to a contractor putting a heat pump water heater in. It's the same electric, it's the same physical size, but it needs a condensate drain because a byproduct of using a heat pump water heater is that it will remove humidity at the same time that it runs. Now, it's not exactly like a humidifier because humidifiers run all the time. A water heater only runs when you're doing one thing, using hot water. So it's not something you can count on, but you certainly feel the benefit of humidity reduction where the water heater is. And we're going to talk about after sales support because for contractors, this is not a product they're familiar with, even though it's been in the industry for 13 years. 13 years. This isn't new. This is 2 products that have been in the market for a long time, a standard electric water heater and a refrigerator merged together. A refrigerator that's running in reverse because refrigerators are heat pumps. Their job is to take heat out of the inside of the box where you put hot food and to release that heat to your feet in the floor. So the end result is the more heat you take out, the further the temperature drops and the colder it gets inside. So that same principle was applied to a heat pump water heater that says, let's take some heat from air around it and move that inside the tank. So we're going to talk about after sales support and understanding, one, that they're very reliable because refrigerators in and of themselves are very reliable and electric water heaters in and of themselves are very reliable. So you put those 2 things together, you continue to have a very reliable product that you can count on. So how you heat your water really does matter. When you can hit a home run by getting the highest in efficiency up to a 4.02, and you can use 3,000 to 4,000 less kilowatt hours a year in every home, and you're using a renewable energy in most markets and no greenhouse gas emissions directly from the water heater. This checks off all the boxes that anybody would ever have. But the best part, again, is that it applies and resonates with all Americans that are considering how they can save more money by saving energy. So how did this all get started? Well, it began way back in 1992 when Energy Star created that first label that said this blue label is going to be applied to products that use a significant less energy for all kinds of products, and they will earn this label as a result of that being first in class. So Energy Star goes to the HVAC industry in 1992 and says, can you create a product that uses significantly less power than what you use today? Can you create some higher efficiencies? And that industry said, yes, we can. Well, it took from 92 to 95 for the first Energy Star HVAC product to come to market. And that product stood out head and shoulders above the rest because it used less energy. Well, HVAC, that heating and air conditioning, that's our highest energy user in the home. That really makes sense to go with an Energy Star product for that. Well, when the Energy Star folks approached the water heating industry said, we're not really sure what else we can do to make this product more efficient. We can add some insulation or change the style of insulation, but electric water heaters are heating elements in water, and gas water heaters are 40,000 BTU blowers at the bottom, blowtorches that heat tanks. So there wasn't a whole lot of room to be able to make some moves until tankless water heaters came out, and they bumped up the efficiency some, but still did not even get to 100% efficient, meaning you get $1 in hot water for every $1 you spend. So it took actually an appliance company, GE, to say, we think we can figure this out. We build heat pumps every day, a few million of them in the course of several years. They call them refrigerators. Let's take those same components that are on a GE refrigerator and let's attach it to a tank of water, but let's run it in reverse. And when we do that, we're going to be able to move heat rather than creating heat, but we're also going to put the heating elements inside so that it does both. And that became the first ever Energy Star rated water heater way back in 2009. Now that spawned this whole industry to where we are today with all the major manufacturers in this business, producing heat pump water heaters, producing unitized product, producing some split product. But the goal of that in the original intent was 50% of American homes, the half of American homes that have electric water heaters. The simple job was to let's replace those. Let's take electric water heaters that exist today that already use a 30 amp service and take those out and just replace them with a heat pump water heater. The homeowner doesn't compromise in hot water quality. They don't compromise in hot water volume. They simply reduce their energy usage by about 3,000 kilowatt hours. That was a home run. What we didn't see coming at that time was that the gas side of the equation was also going to begin to play in because of the state of California. California, a huge state, 93% of the homes have gas water heaters, and California has decided that they want 100% of their homes to have heat pump water heaters. That's where electrification and decarbonization come in. So this product that was designed for the 50% of American homes that was the easy putt, the easy thing to take one out and put another one in, is now being affected by the gas side of the business that says, I got to make sure that I've got room in a panel box for a 30 amp service. I got to run that line over. It costs a little bit more to do that. And that simply means that the payback story gets stretched out a little bit further. So when you look at all of these things, this great product that already can be adapted to half of American homes is now going to become the mainstay in 100% of American homes. Now, we got a new vocabulary that we got to look at. Yes.
Yeah. So on that gas note, I'm glad you brought that up because one of our attendees wanted to seek some clarification on the 300% claims. Or, those claims, those are typically on a cost basis anyway. I suspect related to comparing a heat pump to an electric resistance. Maybe on a carbon basis, there's some conversation there as far as the percentage. But just can you speak to that real quickly when you're saying 300% efficient, 400, that you're speaking more towards resistance? Is that on a cost basis anyway?
We're talking about overall efficiency. The Department of Energy measures efficiency on water heaters with a UEF, which we'll go into in more detail a few slides from here. Now, when you look at a UEF, that simply means that the DOE says we're going to take every manufacturer's water heater, whether it's gas, electric, tankless, whatever it is, we're going to put it in a test chamber with 68-degree ambient temperature, because that's the average temperature in the home where water heaters are located. We're going to run 57-degree water through that, and we're going to simulate water draw patterns that are like for like with every different size tank and the intent of that product. And when we finish doing these draw tests, we're going to measure the volume of hot water and the efficiency of energy, what it took to be able to produce that volume. And that's where they come up with a UEF rating. Well, the UEF on a standard electric water heater is 0.93. That means that in standby and other things that occur, it loses about 7 cents of every dollar you spend to heat water. But the UEF on a heat pump water heater, because it's capable of both moving heat and using resistance heaters, comes up at over 3.0. Some manufacturers up to a 4.02. Now, how can that possibly be? Well, it's like the law of fluid dynamics, and it's also just the law of using leverage. Let's say I give you a 200-pound piece of metal and I put it on the ground in front of you and I say, bend over and pick that up. For some of you, that would take every ounce of strength you have to pick that up and hold it over your head. And you'd say, I did it, and now I got to sit down. Then I could take a rope and a pulley and put it in that same room and say, now pick this up using this rope and pulley. And now you take half the energy. And with two hands, you're able to pull a rope and say, now I picked it up and it didn't kill me. And now I can say, let's put a block and tackle up there. With one hand, you're now picking up 200 pounds because of the physical dynamics of what is happening with that block and tackle. You're still picking it up, but you're using a fraction of the energy. That's what happens when you move heat, and the HVAC guys on this call can jump up and cheer for that explanation. I've got a water furnace system in my house as well, so that I've got lateral lines out in the yard that says I'm going to absorb heat in the wintertime and bring that heat in, amplify it, and use it rather than creating it. And in the summertime, I'm going to extract heat from my house and send it out to my geothermal lines, and I'm going to get rid of it. And the more heat I take away, the cooler it's going to get in the house. Mm-hmm. That's the way the principles of efficiency are going to work in this: energy in, heat out. And for a heat pump water heater, they're capable of giving up to a 4.02 UEF, which means you're getting about $4 in hot water for every $1 you invested to be able to do that. Yeah. It's not necessarily a direct carbon relation, although it is going to reduce carbon drastically since it uses less overall kilowatt hours in power, 3,000 less on an average. That means the power company is not having to generate that to send that out, and the product itself is not directly emitting any type of CO2 gases. Does that help?
Thank you. I think I'll let them follow up, but yeah, thank you.
All righty. So we've got electrification in California. That's a term that comes back from the 50s and the 60s when electrification was being expanded across the company. You got decarbonization, greenhouse gas emission reductions. You've got these dates of 2025, 2030, 2045, 2050. Every major city in this country is on a decarbonization parallel path right now, from New York City to Boston to Denver, Colorado to Baltimore. All of these cities, all of the major cities, even Columbus, Ohio, down the road from me about 3 hours, is saying we have goals for decarbonization. So what they're doing is eliminating the gas infrastructure. They're just stopping it. No more new subdivisions in California, no gas infrastructure, which means the cost of natural gas, if we apply the laws of supply and demand, that if you still have the same infrastructure across the state to supply gas, but you're not using the volume that you did, what are we seeing already happen to the cost of natural gas? It's going up. Now, natural gas water heaters, as we'll learn in a minute, have never been as efficient as electric water heaters, and that's going to begin to show when you look at the energy guides, as I'll explain in just a couple of minutes. But I just want you to make sure you understand these terms and the switch and the move that is taking place to make everything electric. So you got new terminology. You've got heat pump water heaters, which are also called HPWHs, or hybrid heat pump water heaters, or hybrid electric heat pump water heaters. The hybrid part of this just simply means two. It's got two fuel sources. It's got a heat pump that says I can move heat until I can't keep up, and then I'll switch and either add a heating element or just turn the heat pump off and bring on the heating elements. But the heat pump is always the first line of defense and is the major supplier of the hot water. In fact, if you put a heat pump water heater in a heat pump only mode, it will get to 140 degrees in the tank, just like standard electric heating elements do. It just will take it longer to get there. So you put a properly sized tank in a house that you don't run out of hot water on every day because it's properly sized. And all that means is you take showers in the morning and you use the water up that you needed to because you got a properly sized tank. You go to school, you go to work, and what happens while you're gone? The heat pump may run for 3 hours, but it's only drawing about a 0.5 kW draw, whereas a standard electric heating element that will recover in 1 hour is drawing 4.5 kilowatt hours. It's recovering fast for no apparent reason because you may not even be home. So you have to think all of these things through when you look at the value of a heat pump water heater. They're all tested in the hybrid mode that says you run your algorithm, manufacturer, you figure out how you want that to be, and we're going to test it at the DOE to verify how it works and the efficiency. But in that hybrid mode that you're going to now have to ship your water heater out to the American home, we're going to know that it's got the efficiency that we tracked. So it's not a surprise to say that a heat pump water heater can provide $3 or $4 in hot water for every $1 you spend, because it's tested in the operating mode that you get it in. Now, could you save more by taking it and putting in heat pump only? You could. But when you're already down to an operating cost of $113 a year, what you have to ask yourself is, how much more can I save? I'm down to $113 and I was at $419. So could I save $5, $8 more, $10 more a year? I probably could. It's all a matter of how many people are in the house and what are my living patterns to where I would ever bump into taking a cold shower because it takes too long to recover in that mode. And that's the balance that a homeowner is going to figure out on their own. Most people leave it in the hybrid mode and say, I don't even want to think about it. I want the same volume of hot water. I want to be able to think that you could have replaced it in the middle of the night and that I feel and experience no difference in my life as a result of that heat pump water heater being in. And that is the way they truly can work. So you've got heat pump water heaters, you've got unitized heat pump water heaters. That's a one-piece system. It looks just like a standard electric water heater. The heat pump is in top. It's a compressor, condenser, and evaporator, and it's enshrouded so that it looks just like a little bit taller tank. You also have split systems that are two pieces, one inside the house and one outside the house. And there are different manufacturers that do each of these, and this is what they look like. You can see that there are 3 brands on the left that build a unitized unit. Those are 240 volt. These are the highest performing products because they've got 240 volts of energy. They've got heating elements inside, 4,000 or 4,500 watt heating elements. So they can perform just like standard electric water heaters that people love today, half of American homes. Then you've got a 120 volt unitized unit there in the middle. That 120 volt model does not have a heating element. It's designed primarily as a replacement, specifically in California, for those homes where it may not be practical to try to bump up the panel size for the power company to spend the extra dollars. So now you got a water heater that you can actually plug in that's only going to use 120 volts, and it's going to take much longer to recover. But if I've only got 1 or 2 people living in an application in an apartment like that, they're not going to use up and take showers in the morning and drain the tank and then turn around and say, that was so much fun, let's do it again. They're going to wait. They're going to wait because they don't need that quick recovery. So you have an option there. And then you've got the 2 split systems that you see on the right. With those products, you've got one part that's outside, kind of like a split HVAC. But the difference is there's a water line set only that goes from outside inside to the tank. Those can be used as replacement They're more prominently used for new construction. The models on the left that are unitized were designed directly for replacement and new construction. So you can see the difference in different conversations and different operating temperatures that you would have for these. So you've got to size the tanks properly. Heat pump water heaters are standard electric water heaters with a heat pump. Every manufacturer has a sizing tool on their website, and it's the basic sizing that the plumbing industry has always had. That says electric water heaters don't get sized the same as gas water heaters. And you architects that are out there, this is really, really important for you to pay attention to. A 50-gallon gas water heater will outperform a 50-gallon electric water heater every day of the week, because it's got a 40,000 BTU blowtorch sitting under it. It can produce more volume of hot water faster than the limitations of a 4,500 watt heating element on a 30 amp service. So you size according to the manufacturer's instruction, according to national code, which again, following just electric, you're not following a heat pump water heater sizing. It's an electric water heater sizing. These happen to have a heat pump with them. So expect the manufacturer to educate your contractors. If you're a utility running a program, if you're a builder that is putting these in, expect the manufacturer to help educate the contractor, the mechanicals, the architects, to be able to know what space is required, what do you do in case of service, and so on. Now, for installation, you can use mixing valves on these. Some requirements or some states actually require that. If you go into the state of Vermont, every water heater in the state of Vermont has a mixing valve on it, because that allows you to bump up the temperature in the tank to 140 degrees and then dial it down with a mixing valve that sends it out at 120 or 25 safely to the home. That means you get more volume out of a tank with hotter water because you use less of 140 degree hot water in a shower than you do of 120 degree hot water. So just being able to set the tanks up properly makes a difference in customer satisfaction. You need a dedicated circuit for a 220 volt, 240 volt heat pump water heater. You generally need a 200 amp panel, not always, it just depends on where the house is located. And you can use recirculating pumps for some manufacturers, not for others. So always check with the manufacturer to see what they say about that. And you might say, Greg, why would that be a problem? Because not all recirculating systems are equal. Some people decide to put a recirc line in that is essentially a space heater in the home that says, I'm going to keep the hot water lines hot 24 hours a day with 120 degree water, because somebody's liable to come home at 11 o'clock in the morning and decide they want to take a shower or wash their hands and they need to have hot water readily available at the sink. That's not a smart system. And there's not a manufacturer out there that says we'll go along with that, because that's going to make the water heater, heat pump, gas, whatever it is, pretty much run all the time. So you want a smart system that says I've got a proximity switch in that furthest bathroom. I've got something that a homeowner can push or activate, or that just by walking in causes the recirc pump to activate. Or at worst case scenario, you have a timer on the recirc system. You program that with the homeowner in mind that says, what time do you get up? Well, Monday through Friday, we get up at 4 o'clock in the morning. Well, at 10 minutes to 4, we're going to run that recirc line and recirc it so that when you walk into the bathroom, you have hot water waiting for you. Smart recirculating system only. Any questions on that? And I'll pause for just a second, take a sip of my coffee.
Well, there might be, but I want to go back a little bit up to the top here, because there were some questions on, some of this new technology that's going to allow folks who, maybe can't afford older existing homes, people who are struggling but want access to a heat pump, can't afford all the electrical reworking, and it's going to allow them to do 120 volts. What are your thoughts on, that kind of technology?
Here's the biggest risk you have with 120 volt. If you take somebody off of a gas water heater, and especially if it's somebody that has a gas tankless water heater that says, I run and I never let you take a cold shower, and now you put them in a volume tank of some sort, a 50, a 65, or an 80, now you've said there is an ability to run out. And now we're also saying, and it might take 5 or 6 hours for it to run and recover. And you can't just have back-to-back showers or more people coming in an hour later taking showers. That is kind of the biggest risk in the industry, as I see it, is that folks that put one of those in may be the first ones to get out and blog and say bad things about heat pump water heaters, but never define that they actually have 120 volt with no heating elements. And yes, it really does take longer to recover, and the industry acknowledges that. So the goal right now is to get people in 240 volt models because that's what they're used to. That's what half the country is already used to. And you can survive on that easily because it provides the volume that you need. It recovers as quick as you need, and you got the different tank sizes to be able to work with. But the last thing we want is blogging out there that says, I hate heat pump water heaters, and then they don't specify, oh, and by the way, mine is only a 120 volt model. It really does take 5-6 hours to recover. I knew that going in, but I just don't like it. Now I'm going to tell the whole world about it. Does that make sense?
Do you think the recirculation pump could be a partial solution if someone did go that route?
A recirc pump would not. A thermostatic mixing valve could help.
Okay.
Because with a thermostatic mixing valve, now I can elevate the tank temperature so that I've got 140 degrees in the tank, which means, again, that heat pump is going to run a lot, but it is only drawing about a half a kilowatt hour to do that, a 0.5 kW draw. So you can bump up the size of the tank, which you would always do that if you're going to a 120 volt model, if you have the space. And that really is the biggest constraint that California has right now, is water heaters are boxed in to a pretty small area that back in 2015, when the DOE created changes in the industry that said every water heater needs to get 2 inches fatter with more insulation so that there's less standby loss. Some of those water heaters had to be jammed into a really tough spot. Well, heat pump water heaters don't have as much tolerance for that. They need air around them. So you can't have a little alcove in the garage and jam a heat pump water heater in it and expect it to be able to circulate the air that it needs when it's only a heat pump, especially, and be able to heat the tank all the way up to 140 degrees. So it is a balance. And as you'll see in some of my next up slides, it really is a balance that 120 volt models should really be kind of, in my opinion, the last option on the table, because that just simply says we're giving up on trying to upgrade the panel box and have any help from the power company, which in California, for a homeowner, it's about a $7,000 incentive to help upgrade the panel box and get a heat pump water heater in the house. In a lot of cases, that absolutely takes care of the cost, and some it may not. But going to 120 volt is my experience in the industry says that's the one that scares me a little bit, because I don't want people blogging, having the ability to do that and not specifying what product they're talking about. We know 240 volt models work. We've got 13 years in the industry to show that people put them in their house and don't ever look back again because they took an electric out and put that one in. It's that gas changeover that can cause some difficulties. Any other questions?
Well, and I don't know if you're going to get into sizing here in a little bit, but there were some questions about, how low can we go? And I've always been curious, will we ever see an on-demand, heat pump water heater? Is that ever going to come? I guess that's just something I've been curious, because I'd imagine you're talking about then zero size, right? So,
well, you've had on-demand tankless. It's gas.
That's what I mean. On-demand tankless heat pump. Yeah.
And you can get on-demand electric.
Right.
But you can't get on-demand electric heat pump because heat pumps take much longer to be able to move heat. On-demand means I can take a shower with a 1.5 GPM shower head or a 2.0 GPM shower head, and it ought to keep up. Now, we learned in tankless introduction 15 years ago that you have to understand what the delta T is in groundwater temperature and the desired temperature at the shower. So those early tankless models didn't have enough heating ability to keep up. And if two showers were going on, it was spitting water out because it slows it down to make sure that the water temperature is right. So when you go to electric, the power companies have traditionally hated any development that had the bright idea 20 years ago to let's put direct electric water heaters in that are on demand. because now they got to have 150 amps just for that, plus what you need in the house. And just because it's not eating anything when it's not on doesn't mean that it's not inefficient when it does work. The best you can hope for in a system like that is to be 100% efficient. I spend $1 to heat water, I get $1 to get water. But a heat pump water heater says you spend $1 and you get $3 to $4. Why would I want to go to a demand system like that that can dim the lights in the subdivision when there's 300 homes that have that, and the power company is like, oh my gosh, what are we going to do every morning when that subdivision wakes up and you've got 130 to 150 amp water heaters that are kicking on for that demand cycle to work? That's the challenge. Got to be able to balance all of that. The grid is important, as you'll see in some of the things we're going to talk about next.
Yeah. Okay. Well, thanks, Greg.
These are also great for solar. In California, solar is a requirement on all new construction today. A requirement. You have to have solar panels. So a heat pump water heater says, I'm only drawing about 550 watts of power. That's about 5.5 100-watt light bulbs. And in general, 2 to 3 solar panels cover the heat pump water heater when it's added to the system. So there's lots of things that you can look at that make that heat pump water heater even more attractive. Now, for contractors that are out there, I always tell people this is really about prioritizing your work, because contractors in general are kind of, if you're out there, I apologize in advance, the weak link to getting these into market. A lot of contractors become reluctant participants because it's a new technology, just like gas tankless was. I got to introduce those on behalf of GE many years ago as well. And I'd go into meetings talking to builders, and builders would say, I want to learn more about this. We're thinking about putting them in. I'd say, bring your contractor in so that he doesn't just hear a sales guy talking about this. And the contractor would be sitting there, and I'd say, this is how it works. This is a delta T. This is how you have to size them. Am I telling him correct? And the contractor would look at me and say, I don't know. I've never put one of these in. I really didn't want to learn about them, but he's telling me I have to. So sometimes this heat pump water heater draws that same type of cynicism of it won't work because you're stealing heat from the house, which we'll talk about more in a minute, those types of things. So prioritizing the work for a contractor means do the easy stuff first. Low-hanging fruit was always the common word we used for that. So electric to electric change out helps the contractor get over the perceived fear of this is going to take twice as long to install, so I'm going to charge a whole lot more to put these in. And I'm like, no, it's a 15-minute job hooking up the condensate drain line. Put a couple of them in and then let's talk again. So they start putting them in and they're like, you know what? You told me this was just the same as putting in a standard electric water heater. It really is. I'm like, thank you. Now you know you shouldn't be charging $1,000 more to put a heat pump water heater in just because it has those words written around it. So start by electric to electric change out. For your utilities, this is the sweet spot. Get contractors comfortable with using these. Get contractors comfortable with talking about them. They should be able to explain them when they're in the home, how it works, why it works, and they should have confidence in the product. Then move to the gas to electric change out. And look for opportunities where you can use that 30 amp dryer plug that is in a house where it has both gas and electric, and they chose a gas dryer. That can be relocated. That can be moved to the garage. That the water heater may even be in the laundry room, and you've got something that you can access right there. Gas to electric, in many cases, the third choice is when you have to upgrade the panel box. And I have said this in California many times over the last several years, and in my presentations there, the first thing that should happen to with any market where you're trying to transform it is the power company should be out bumping up to 200 amps every home, because that's where you're headed. You want electric resistance style induction cooktops in the kitchen. You want HVAC, you want water heating. First thing that's got to happen is you got to get the infrastructure in place first. You got to have 200 amps in the house. Then getting the homeowner to adopt the product is really pretty simple, because the product just makes sense. Induction cooking is fast. Heat pump water heaters say 3,000 kilowatt hours, $300 a year. They're things that just make sense. So remove the obstacles first, then help people to say yes. So let's talk a little bit about how these work, because this really is a simple concept. Heat pump water heaters have electronic sensors on the tank, not mechanical thermostats like most water heaters have today. A mechanical thermostat has about a 15-degree temperature swing. A heat pump water heater says I can detect 1-degree temperature changes. So somebody jumps in the shower, and in order to get hot water out, you have to push cold water in through a dip tube. So water goes in, and the water gets directed to the bottom of the tank, and it starts to stir it up, creating a little stratification. The sensor on the tank says, ding, 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 something's going on. First line of defense, let's turn on the heat pump. 550 watts turns on. The water heater says, I'm now pulling warm air in through the top. I'm transferring that heat through the evaporator to the 134A refrigerant, the same refrigerant that's in most cars, the same refrigerant that's in all of your refrigerators in the house. And it says, I'm bumping that temperature up a little bit. And now I'm going to compress that gas. And when I do that, I'm going to amp the temperature way up. And now I'm going to create a hot gas, and I'm going to push that gas all the way down to the tank. And I'm going to wrap this hot condenser line that would burn you if you touched it around the outside of the tank under 2 inches of non-CFC high-density foam insulation. A heat pump water heater is insulated to about an R19. It only loses about 5 degrees of standby temperature in 10 hours. It means it doesn't run when it's not at home, when you're not at home. It's just sitting there saying, I'm holding the heat and I'm ready to go. And if I do have to turn on, I'm using a heat pump, 550 watts, whereas all standard electric water heaters have to bump on a 4,500 watt heating element. So the heat pump says, I'm trudging along because I don't know how many showers you're taking, and I'm going to monitor some data points of ambient temperature, tank temperature, and a couple of other sensors on the tank. And I'm going to run an algorithm that helps me decide, not based on gallons of water, that's just one factor, but on all of these things together, when and if I need to switch and add something else or turn the heat pump off and switch over completely. So Junior gets in the shower and says, all right, I'm going to drain this tank because at 13, that's what I'm paid to do. And the water heater says, I'm going on with heat pump, doing fine. Oh man, temperature's starting to change drastically. So we leave the standard electric heating elements in. And in this case, the heat pump is going to be on, and it's going to bring on the upper heating element. And when it brings on that upper heating element, it's going to recover the top 30% of the tank where you're actually drawing the water off. Now, if it continues to run and Junior doesn't get out until he completely drains it, then it may flip off that upper heating element at some point and go to the bottom heating element and now reheat the entire tank, running exactly that way with both of these devices on. Each manufacturer is very specific in how this is handled, and it will satisfy the tank. And then it turns off and says, I'm ready to do that all over again. If you leave it in heat pump only, that just simply means that you're going to drain the tank, and it's going to just take longer for it to recover. But it depends on how many people are in the house as to how critical that would be. It's just my wife and I in this big house now. Our kids are gone. Our grandkids, when they all come back for Christmas, I make sure mine is in the hybrid mode. I make sure that the temperature is cranked up to 140 degrees because I'm going to have the pressure of far more people than I do today actually here. But if you went down and looked at my 80-gallon for my house right now, you would see it's in heat pump only. Because with just 2 of us, we're not draining an 80-gallon tank. We're just using a small portion of that every day. But the big focus is being able to understand that you equate this to light bulbs. This is what people have been taught for years, because this is the message of a utility. Light bulbs, light bulbs, light bulbs. Well, this is the equivalent of about 5.5 100-watt light bulbs and a bazillion LED bulbs. A bazillion, that's a bunch. Standard electric water heaters use the equivalent of 45 100-watt light bulbs, and nobody has 45 lights in their house today. Now, the money shot really is this one when it comes to payback, because the higher the efficiency, the more you get. And if you get more than you give, you have a payback story to tell. Only heat pump water heaters have that story. Anything that's less than a 1.0 UEF loses money when it turns on. They can lose 40 cents if it's a standard gas tank. To be an Energy Star gas tank water heater, you have to have a 0.67 UEF. To be an Energy Star tankless, and I typically would ask folks who's got a tankless and what did your contractor tell you the payback time was on that? just for grins and giggles, because most people will say 8 years. And I look at it and say 0.82 to 0.97 means it never gets above 100, which means it can never pay for itself in energy savings. Plus, I have to factor in with a tankless, and every manufacturer builds them, we do as well. You have to factor in that you have to descale a tankless water heater. So there's a difference in the cost of operating a tankless. It's less, but it's more expensive to put in. And the difference is that you got to pay for descaling, which means I now have to invest that money I saved in maintaining the product. Whereas heat pump water heaters are well over 300%. So at that point, you're getting about $3 to $4 in hot water for every $1 you spend. Look at the energy guides, because they tell the story. This is not a manufacturer telling you. This is the energy guide saying that a standard 0.93 UEF 50-gallon water heater at 12 cents a kilowatt hour, which is the current rating that the DOE uses today, it just simply multiplies the kilowatt hours used times a 0.12, and then you multiply the same thing on a heat pump water heater. It's going to be anywhere from $103 up to $113 or $14. That's a big difference in savings. If you look at the gas products at the bottom of this screen, a typical gas, a 0.63, cost about $296 a year, and that's not with the new bumped up cost. Gas has gone up quite a bit. It would actually be well over $300 a year. So when you run these comparisons and you look at it and you say, does it make sense financially? The answer is, yeah, it really does. So let's see here. Let's move on. I want to skip one more. Where can you put these products? You can actually put them in basements. You can put them in laundry rooms. You can put them in garages. You can put them in closets. You can put them pretty much every place that a standard electric or gas water heater is today, provided you've got enough airspace. So basements are great spots. And, the conversation usually comes up with the HVAC guys that says, hey, Greg, you're using the warmth from the house that I had to pay to put in there. The homeowner had to pay to put in there. And if you're using the heat from the house and then I'm having to put it back, you really didn't save them anything. And I'm like, let's talk about that. If you go to my basement where my geothermal system is setting, and if I went into your house, I would ask these same questions. Will I find a supplier return vent in your HVAC room, in your utility room? And I go down there and look around, I was like, no, it's under my porch. It's concrete enclosed. There is no supplier return vent. The reason there's not is because I don't need to condition the space where my HVAC unit is. In most homes, it's not conditioned unless somebody comes along and cuts a vent in somewhere that says, I want to heat this area for whatever reason. Now, what makes the temperature in that basement what it is the fact that it's 8 feet underground. And I've got free geothermal heat pressing through that says that ground temperature is pressing into my basement. And I know this because in January and July, it's the coolest part of my house because it's 8 feet underground. In my case, it's 9 feet underground, 10 feet underground. So I'm using that free heat. A heat pump water heater only needs air above 35 or 40 degrees in order to be able to make that transaction take place. The DOE rating for this is based on 68 degrees. So if my basement is 60 degrees, 57 degrees, that means I'm a little less than the rating that it shows on the water heater, but I'm still way above the 9.93 that a standard electric operates under those same conditions where it's not doing as well. Just the same. So I'm still going to have about a 70% energy reduction, even if I do that. And then I remind folks, if this puts off a little cool air, which it does, and it's in my basement, am I going to find a return vent right next to my HVAC? And the answer to that is ding, 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 no, because the return vents are upstairs where I'm conditioning. The supply vents are upstairs where I'm conditioning. And where's the thermostat that makes the whole system run? Upstairs where I'm conditioning. So if that's the way my basement is set up, and if I make that space even cooler than it already is when I walk downstairs, is it changing the performance of the house? And the answer is no. This was proven and studied by NEA, the Northwest Energy Efficiency Alliance, in a 1-year study in 2 test homes where they moved water heaters around for a year, different rooms, basements, upstairs, garages, in bedrooms, everywhere. And they said at the end of that time, there was not a significant difference in the performance of the home enough to say you need to vent or move that cooling effect air. Is there a question?
Yeah, there's two questions related to placement. And the first one is, what about, ducting these systems? What are your thoughts on doing something like that? Can that be done?
Heat pump water heaters can be ducted, and the only reason that there are ducts even available for heat pump water heaters is because NEA was going to create another tier many years ago that said we're going to require venting for heat pump water heaters. And I used to go out for those conferences in my GE days and argue every year. Water heaters in your market for the NEA market are in the basement, and hot air rises and cold air falls. If I'm not mixing the air and it's cooler in the basement and it's not affecting the performance of the home, why would you want to vent? Like, well, we think it is. So finally they said, we're going to prove it. And they did this double study, 2 identical test homes sitting side by side, unoccupied. And they moved the water heaters around, a standard electric and a heat pump water heater. And at the end of that study, which is published and online, they said the only place that we found was a bad idea where to put it is in a closet in the hall, right across from where the thermostat is for the HVAC, because when the heat pump water heater runs, it's moving that cool air through that louver door, and it looks like it's bouncing against that wall and falsifying a reading on the thermostat to make it think the whole house is getting cooler when it's not, and then it was bumping up the heat. That was it. That was the only space they said, that's not a good idea. So the answer is no. If you push air out of a house, what do you have to also do if you got a nice tight home? Bring air back in. If a heat pump water heater needs 35 or 40 degree ambient temperature, are you going to pull that in January and February in a market that it's 0 outside? You're saying no, the heat pump water heater is not going to run during that time. It's all resistance. Now, every manufacturer has the ability, if it's in a slab construction and if it's in a spot where grandma is in the kitchen and says, there's cold air coming from that closet, I got 3 Afghans wrapped around me and I'm not leaving until I can get warm, then you walk over to the water heater, you put it in standard electric mode. On some manufacturer's product, a timer pops up that says how many days. Up to 99 days, I could tell it in January. And let's go for a 30-day stint at just being standard electric, and then it will automatically switch back to the hybrid mode. Automatic. You don't have to remember, you don't have to set a timer on your phone. Would it be better to save energy 11 months out of the year or to just keep the old water heater and save 0? That's
right. And you make a good point. And you had mentioned, and this is some pushback we received, like with senior housing apartments and concerns about putting these things there and freezing the room or drying it out. And so in multifamily housing, let's talk a little bit about placement in that regards. If somebody's concerned and they want to get it out of that room, obviously the only other choice that we typically see are these massive boilers, massive sized boilers. I assume we don't have those yet downstairs. And so are there any in-betweens between in the closet and this big massive boiler approach to multifamily?
Well, you can spend a whole lot of money on a central heat pump water heater, which there are many manufacturers that produce those for multifamily. Okay. But the easiest solution in some of those cases is just simply teach the homeowner or use the app that the manufacturer has, because all of these brands for the Unitized all have an app and a phone. And on some of them, if it was a contractor or an apartment that says, I got 100 units here, one guy could have control over all 100 of those water heaters. And he could say, during these colder months, boom, 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 I'm going to put them all in standard electric for a short period of time because I don't want to deal with complaints. Again, the idea being, do you put an energy efficient technology in and say, even if I only get the benefit of 11 months or 10 months or 9 months out of the year at an optimal energy efficiency, would it be better for me to still put it in and just say, I'll just compromise that rather than keeping 12 months out of the year of losing 7 cents of every dollar you spend to heat water? You're making your best choice out of that. And that's where NEA landed on this. And they took the venting requirement off the table. Gone.
And keep a note on that. You don't have to respond now, but there are several people asking to request that study if you can send a link out later on the venting. So
Yeah. Yeah. If you Google, yeah, I can do some stuff on that. Yes.
All right, thanks.
Now, what is the same? I'm sorry. Anything else?
Not
Okay.
right now.
All right. So this is what I like contractors to see. What's the same as a standard electric? It's got the same first hour rating. The number doesn't change. So contractors automatically assume because it's a heat pump water heater, I have to put it in a bigger size for an electric to electric changeout. And I'm like, no, read the spec. FHR, first hour rating, exactly the same number on a 50, a 65, or an 80 as a standard electric alone. Now, some of these products are designed to fit in this exactly the same footprint. Some of them have top connections. Some of them have side connections. There's one manufacturer that has both on the same water heater. So it depends on what you're doing. If you're in the replacement market and you're taking out a top connection water heater, putting a top connection water heater is going to be your fastest and easiest choice. If it's new construction, side connection doesn't really matter because you're moving the plumbing in there anyway. But as an architect, you need to know that when the brand is chosen, because it's going to determine where you're going to see that plumbing coming through and how much space on either side you're going to need for those pipes to go all the way to the floor. 30 amp service, 208 to 240 volt is standard for all of them. What's different is the fact that you need air, and 700 cubic feet is generally the accepted number for every manufacturer. NIA did do a study that some of you may have heard about called the Incredible Shrinking Room, where they took one manufacturer's product and they said, we're going to start shrinking the room down to make it smaller, 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 and we're going to measure the decline in efficiency. And we're going to just tell people essentially with this product that they could go this much further down, and yeah, they're going to give away some efficiency and they're going to cost more to operate, but we think it's still worth the trade if that's the only way you can get the water heater in. What that doesn't mean to a builder, and you architects, please hear me when I say this, it doesn't mean that you size new construction to the closest, tightest standard today and think that that's what it's going to be 10 years from now. You got to look way ahead and say, for a builder, I need to make sure that I've got 36-inch space. A 36-inch square for a 50-gallon water heater means it can be serviced in that space without removing. Anytime you push a water heater up against a wall, you're at risk of a contractor coming out and saying, I can't take the top off. And if I can't take the top off, I can't work on it. And if I can't work on it, that means I'm going to have to drain the tank, take the connections off the top, pull the tank out, take the top off, diagnose it, hope the electric line will reach, make the repair, put it back in, hook it all back up, and hope that it all works right. So don't do that in new construction. The last thing you want is a builder's reputation on the line for a subdivision or a multifamily project where 10 years from now, whatever the latest technology is and whatever the DOE begins to require, all of a sudden needs 2 inches more space or some other configuration to go in. And all of that, builders' homes don't fit without major modifications in construction. So go with the maximum that you can right now. Yes.
Real quick, Greg, are you going to be able to stick around for a little bit longer and keep going?
Yes, if they're okay with that. Some of this I'm going further in depth, and yeah, if it's okay with you guys.
Great. Yeah, I just want to remind those of you who do have to get going, as long as you've been here for the entire CEU approved time, you are approved for your continuing ed, and you can leave now. You're as long as you've been here for the entire session. We don't want to hold you up, but we do encourage everyone to stick around, keep asking questions. We got a lot of great questions. We're going to try to get to them, and we're going to keep going. But thanks again for joining us, and we'll catch you next week if you do have to leave.
All right, so what's the same? Now let's talk about what's different would be the air requirements. The 700 cubic feet for you architects, that's 240 square inches of free air. If you actually have a louver cut in, that means you measure the space between, and that specification is written on all mechanical louvers of what's the gap between all of these added up to 240 square inches. It generally means you would want a top and a bottom louver, and they're going to be almost as big as the full louver door that you see in that picture. Most of these can be pushed up against the wall in a pinch for replacement, but should never be handled that way for new construction. The condensate is 2 quarts of moisture maximum a day. It's not like an HVAC product that removes tons more. This is going to be far less because heat pump water heaters only run when you're doing one thing, using hot water. So you might have 3 hours in the morning, and you might have 3 or 4 or 5 hours in the afternoon or evening, and that's it. All of these have a requirement with an air filter on them that needs to be monitored and cleaned, not replaced. And they all have air sensors on them that will cause that alarm to go off to get the homeowner's attention. Now, when we move on to a typical installation, you're seeing some of the differences here between a top installation, which is typical of a water heater today, versus a side connection, versus another manufacturer that actually has side and top connections, and you can decide which one. You just want to make sure you've got the space around the water heater to be able to accommodate that. And also note that if you do use a side connection water heater, being able to use a vacuum relief is essential. That's part of plumbing code to make sure that that product is on there. So that is something that sometimes can be overlooked. You're looking at some typical installations here and what they can look like when they're installed a little bit closer. And that vacuum relief valve right here that's not supplied with those water heaters. You want to make sure that the contractor fully understands that. And clearances, you can put some in alcoves and twist them. You want to follow the manufacturer's instructions when you look at that. And this is the one thing where every manufacturer spends a lot of time teaching and training to make sure that contractors are comfortable doing this every single day, because they need to be really good at heat pump water heaters, since this will be the primary thing that they're installing. So be sure and read the instructions. Venting is rarely used. As you can see, even in some of these pictures, there are kits that can be added, or some come ready to be vented. But I can tell you, I can generally count on one hand in the course of a year how many projects I see actually use venting. And I always will encourage any contractor, any builder, before you make that venting choice, talk to the manufacturer, because 9 times out of 10, the manufacturer is going to show you why venting is not going to be needed. You're getting to look at least one plant right here. These water heaters are made in lots of different places, from Mexico, China, Germany, and Middleville, Michigan. You can see kind of what they look like. It starts off as an electric tank, and then it gets a condenser line wrapped around it under 2 inches of insulation. So these are not something it's not a new technology. It's a blending of 2 old technologies when you see it work. There are some common myths about heat pump water heaters that say they don't make enough hot water. And we've already talked about this. That's not true. Just look at the first hour rating. They'll say they're challenging, they're harder to install, and contractors sometimes will do that and say it takes more time. And I'm like, it's a condensate drain line. That's the difference. It's not really going to take you that much longer to install, 15, 20 minutes and $20, $30 worth of PVC. Or they'll say they don't work in cold climates, and that's usually where I get my best joke in, because I tell people, I say, I may be a Kentucky boy, but in Kentucky, we put our water heaters in the house. Where do you put yours if the cold climate makes a difference? Because water heaters are in the house. It doesn't care whether it's 0 outside. It's in the house, and they will absolutely work. Or they'll talk about how they make a lot of noise. This number is actually changed. Every manufacturer is below 50 dB. Well, the sound of a dishwasher is about 55 dB. The sound of the newer dishwashers is now below 50, and that's in the 40s as well. Considering where a water heater is located in the house, people typically don't hear them. The only cases that I hear where sometimes they do is if you push some of them against the wall and bolt them to it. Some manufacturers include dampening pads because it may be that their compressor or fan resonates with the studs in the wall. You got to watch that part of it and make sure that it's installed properly, and you should not normally get any kind of a sound complaint. Will they work in a garage? Yeah, as long as the garage is above freezing. And water heaters that are in garages today are obviously above freezing most of the time. All that means is with a heat pump water heater, if it temporarily drops down because of an unusual event in the panhandle of Florida and it gets freezing, that just means the heat pump won't work, but the standard electric heating elements will. You can even put, some manufacturers will allow installation in attics. Others will not. You always want to check with the manufacturer, because coastal environments a lot of times have heat pump water heaters in the attic. Condensation, you got to protect it from freezing. Well, there is no condensation being removed in the wintertime. The HVAC system is taking care of that with the heat, and most people are trying to introduce moisture to the house, so there's no concern about it freezing. And they'll say, well, do you have to be a refrigerator technician? Well, no, you didn't have to be a technician to install the refrigerator in your kitchen. You don't put a heat pump water heater. It's a sealed system. Now, there is a difference in manufacturers when it comes to what's serviceable. Two manufacturers will allow electrical repairs, fan components, and plumbing components, but not sealed system. And one manufacturer will allow all of it to be fixed in the house, just like a refrigerator in the kitchen. All the manufacturers have 10-year warranties on all the parts and 1 year labor. And as I said, two manufacturers would require the replacement of the water heater if it's a sealed system problem. And that, just remember when you're talking about this, for either one of those, labor is 1 year. So if somebody has to have one replaced in 5 years, the homeowner is still going to be responsible for the labor of diagnosis, uninstalling, reinstalling, etc., or for a refrigeration guy to come out, just like you would, again, the refrigerator in the kitchen, and replace a compressor maybe. 10 years of free parts, even heating elements, 10 years for all of that. And then they'll say, well, they cost too much. Well, you know what? Tankless water heaters were 2-3 times the cost of a gas tank in the home. And that's now what, over 15% of the market is tankless water heaters. People will spend the money to never take a cold shower. They'll spend the money on this so that they can get all their money back. They get the payback story. And next year, when you've got a 30% federal tax credit, 30% up to $2,000 of the installed cost of a heat pump water heater, plus the utility rebates that range anywhere from $600 to $1,000. The number one place that heat pump water heaters go in today is the state of Maine. They put over 10,000 in every year. They're at about a 60% market penetration in the state of Maine with an $850 instant midstream rebate. That is the key to success. If it's not an instant midstream, contractor walks in, sees the discount off the price that he pays, you might as well not do your rebate, because they're not going to be effective. And we've got 13 years of history that prove that. We talked about the sound level. All are below a 50 dB. And finally, service. Every manufacturer handles the service side a little bit different. Read the warranty, understand the manufacturer. Some manufacturers are open 24/7. Others have different hours. Everybody's got a toll-free number to be able to call. Just make sure you understand that part of it. Now, this last thing I'm going to give you is a generic version of how to talk about these in the house, because really this is about telling the story. This is about proactively getting contractors in the area that say, I'm not going to wait for the phone call of a failed water heater to sell a water heater, because today you only sell water heaters when a failure occurs or new construction. The HVAC guys out there, you guys know every house you walk into, you're more likely to see a lesser performing system, and you can upsell them to the latest Energy Star product. I teach this to plumbing contractors every day the same way. Think of every house as an opportunity. If I'm in 3 to 5 houses today as a contractor, and in my business I've got 5 trucks that run, that's 25 opportunities a day, 250 chances every week that my guys are in somebody's house because they liked us well enough to call us out to make a repair. I owe it to that homeowner to talk to them about taking out a non-Energy Star water heater and putting in an Energy Star water heater that pays for itself proactively. Why would I wait and keep a standard electric water heater that's 3 years old for 3 more years because it's still under warranty? I'd be giving away $900 that could have been paying for the heat pump water heater. I'd be passing on a 30% federal tax credit. I might be passing on a utility rebate that in 3 years doesn't exist because the market has changed that much. So teaching contractors how to do this by putting their company logo on a sheet that says, put this on your phone, so when you're in the house, you say something like this: Mr. and Ms. Homeowner, while I was here, I did a courtesy check of your water heater after we finished fixing the clogged drain that you had. Want you to know I didn't find anything wrong with it other than the fact that you've got a water heater that uses way too much energy. We'd like to take that out and put an Energy Star heat pump water heater in. And I don't want you to get nervous when I use the word heat pump, because I've already counted, 4 or 5 of these in your house. They just have different trade names. They're called refrigerators, dehumidifiers, bar refrigerators, freezers, your HVAC system. These are all compressors, condensers, and evaporators that you know and trust every day that last a very long time. Well, this manufacturer that I represent has one that's attached to a heat pump where they took the same compressor, condenser, and evaporator, kind of like what your refrigerator has, and added it to this heat pump. And what that means is that we're going to be able to use the heat pump to move heat rather than creating heat, but we also are going to leave the electric heating elements in. And when I do that, I'm going to be able to save you about 70% on your electric bill. What that means is that instead of spending $419 a year, you're going to be down to $113 a year just by taking this out. And this really is about using incandescent light bulbs, 5.5 incandescent light bulbs versus 45, just to be able to make this change. I'm going to be able to put that money in your pocket. $300 a year on a 10-year warranty product is about $3,000. You're not going to pay the power company, and you're going to get to take advantage of the federal tax credit when you do this, because heat pump water heaters really do pay for themselves and save money. So we're going to get this in your pocket. We're going to give you the federal tax credit with the 10-year warranty. And I only have one question for you today. Why would you wait? Wouldn't you like to start saving now? Can we put one of these in today? When contractors take just a few minutes to educate the homeowner on a technology they've never heard of, and you give them the opportunity to make a business decision, not under the pressure of an emergency replacement, people get interested real quick. What do you mean $300? Yeah, $300 federal tax credit to teach them how to itemize this out. This water heater is going to cost you $3,000 installed, minus your $1,000 utility rebate, which makes it $2,000, minus the $900 that you're going to get in the federal tax credit, real money back. You know, now we're getting that down to $1,100, and it saves $300 a year. So in 3.5 years, just under 4 years, you get all your money back. What else can you do to your home to make that kind of thing happen? So teaching that part of it is the best part of what I get to do every day, because it makes entrepreneurs out of contractors. It helps them to recognize you're helping the homeowner. You're doing them a favor when you take a few minutes to explain that. And you HVAC guys that are out there, you already know how to do that. You're the best ones that I could ever get with a plumbing and HVAC company as a manufacturer, to be able to talk about technologies and to be able to explain how this works so a homeowner makes a good decision. And that's my story, and I'm sticking to it. What questions do you have for me?
Yeah, great, Greg. There are so many questions. It's amazing, the conversation that is going on, and we are not going to get to all the questions today, but we will get them to you. Before we get into those questions, as a quick reminder, yes, the answer is most cases always yes. You can go to our YouTube channel and you can catch this in the next couple of days. We'll have the recording up. You can rewatch it. You can share it with your friends. You can post it all over social media. It's all yours. You can check it out. We want to hear from you there. For those of you watching this in the future, not right now, on demand, go ahead and watch this video and then head over to our Thinkific or USGBC channel and take your quiz with an 80% passing rate. Once you pass that quiz, you will receive your certificates. For those of you who are here live today, check your spam, certs at gutenbergcerts.com. As long as you were appropriately logged in on Zoom, you will receive your certificate of completion sent to your email, maybe your spam, so check it there. And before we get into all these questions coming in, we need to say a big thanks to our board of directors, all of our volunteers, our executive director, Jose Reyna, and all of our top tier sponsors, especially Mitsubishi Electric heat pumps for heating and cooling, not water heating, works very well, and April Air for keeping you comfortable and dry as needed. So thanks to all of them for allowing us to do what we do. So Greg, let's talk about rebates. You know, you kind of ended on rebates. It's kind of going to be a big sales point. And you had mentioned 30%, and I know there's 30% for solar and there's 30% for geo, which is very specific. So perhaps you're saying, you know, 30% is kind of what it comes out to, but we've got the Inflation Reduction Act coming, and we know there's some specific set-asides for water heaters, and to some extent that increases when you're low income. And I know some of that has to be worked out through the states, and we're working on that with our state. And so just, you know, in general, can you speak to what you should know and what should people be on the lookout for as the Inflation Reduction Act dollars hopefully start to hit the streets in 2023?
Yeah, I'd be glad to. There's two things there. One, there are rebates for low income, which is what nobody wants to touch right now because every state has to work that out and nobody has the details. And two, the federal tax credit. There's always been a federal tax credit on heat pump water heaters, depending on the year that it's turned on or turned off. And it's been $300, I think, since the Clinton or Bush administration. And then some years Congress has it on, and then other years they have it off, and then they'll retro it to the previous year. Well, next year, the federal tax credit for heat pump water heaters, and it is a line item on the tax form, is 30% of the installed cost of the water heater up to $2,000. So manufacturers expect next year to be the wild, wild west, because there are going to be more people interested in putting heat pump water heaters in when they see that payback so quickly, because you still have a utility rebate. And if you don't have one in your market, you should be talking to your utility about what you would expect. And as manufacturers, we all work with the utilities to be able to help them understand that a utility rebate has to be instant and midstream. It has to be something that the distributor takes off the cost of the water heater, no paperwork that a homeowner has to fill in and hope that in 2 or 3 months they get their rebate. Instant and midstream gets contractors and homeowners excited.
Yeah, and one other thing I think is some of the updated rebates for new construction. So the 45L tax credit, or the 179D for multifamily renovations. I'd imagine heat pump water heaters are going to easily help you achieve your energy savings and your better HERS ratings to help you. So even though those don't call out heat pump water heaters, they're very performance in nature. The heat pump water heater is going to help you achieve those lower energy savings, or higher energy savings, or higher or lower HERS ratings, right?
Exactly. And for the last 13 years, heat pump water heaters have been something that manufacturers like myself have spent a lot of time talking to HERS raters about, because when it comes to lowering a HERS score 4 to 7 points, this is the least expensive technology you could put in a house to say, look, we can get your score down, and it's only going to cost you for the product itself or an installation for your plumber, $2,000 or $3,000 versus twice that much if we have to update windows or HVAC or insulation or do something more, air exchanges, things like that. So you start looking at that total package and say, what am I paying per point? A heat pump water heater is the best value proposition for the volume of points that you gain, and builders begin to get that attention right now as they put these numbers in.
Yeah. Now let's talk about a little bit about time of use, peak load shaving. I understand that a heat pump water heater, this big tank it can essentially gather up energy when the grid is maybe less carbon intense. There's more renewables and it's less costly, quite frankly, right? I'm in a time of use period. I was forced into one. I was gladly to go into it. I love it, the idea, but we were all forced into it here in Michigan, in West Michigan anyway. And so how can we use our water heaters to intelligently, maybe heat water when there's less carbon, less cost, and then not heat it when the grid is more carbon intense, more costly? Is that something, that you all work on? And what can you tell us about that?
Yes, and every manufacturer takes a little bit different approach to this. You can program pretty much everybody's water heater to say, because utilities advertise, in California especially, they'll say at 3 o'clock in the afternoon, cost per kilowatt hour goes up, and it stays there until 7. You could go to your heat pump water heater using your phone and say, I'm going to program it so that during that time, I'm not even home. I'm just going to tell it to turn off. Or I am home most of the days. I'm going to tell it to go to heat pump only mode during that time. So that if I need to replenish the hot water, I'm only using 550 watts of power, and I'm willing to pay a higher cost per kilowatt hour to have uninterrupted hot water. And that is something that as a manufacturer, I spend a lot of time talking to utilities about. The history in this country of water heater programs is we want you to sign up for a program where we can turn your water heater off at will, and we'll give you a whole $5 at the end of the month if you'll do that. And then they wonder why the percentage of participants is somewhere between maybe 3 and 9, maybe 10% if it's a really big utility. And I always tell people, if you tell people you'll never turn off the water heater, that the worst you're going to do is make it take a little longer to recover under some circumstances, your participation rate will go through the roof because people will say yes to that. But if they've ever had a bad experience with an HVAC getting too warm in the house during the summer, your participation rate starts to go down. But you can program a water heater like mine, as many programs as you want, depending on what's going on. If you've got multiple times a day that they change, which they don't right now, most utilities have 1 or 2 events programmed per day, and that's it. Now, if a utility, when they get further advanced, since all of these water heaters have CTA 2045 adapters plugged in as part of the water heater, or that can be added and placed somewhere within 100 feet, then you now have the ability to let that utility talk to the water heater. But I can count on one hand how many utilities do that across the country. And generally, it's only like, a couple of fingers that are actually doing that. So the preparation of getting these water heaters all equipped with this is done. Every manufacturer has it. Now it's really a matter of a smart homeowner saying, I'm going to find out from my utility what the schedule is, and I'm just going to program it in myself. And I get to have control over what I'm going to do. Later on, you're going to see some utilities that'll say at 10 o'clock at night, we still got a lot of generation going on and we have no place to put it. Can we put a mixing valve on your water heater and give you a couple of dollars to let us jack up that temperature late at night so that you wake up in the morning with a 140-degree tank automatically? Yes, all of these manufacturers will be able to do that, but there's no utility doing that right now.
So refrigerant, you mentioned this has a refrigerant like anything else, like your air conditioning, right? Your refrigerator.
134A.
What we know about refrigerant is it's got a very high global warming potential. It can leak, very concerning. So what do you think or hear or know about, new heat pump water heater technology that's coming out that, uses less global warming potential, maybe CO2, what's possible out there?
CO2 has no effect on global warming, as I understand it. It is the safest of all of them. So using CO2, but CO2 heat pump water heaters are exponentially more expensive. So if your global warming intent as an individual is to have a minimal impact, get your checkbook out and write the check for that one, because you're not going to have any effect then. But 134A refrigerant is a well-balanced, well-used, as I said, most cars have them and most refrigerators in the house. And I know there's a lot of folks that'll say that about, how much gets leaked in the atmosphere. I'd be curious to ask, of all the people that are on this call, how many people have actually experienced a sealed system problem with their refrigerator ever in their life? Most will say, no, I got a 30-year-old refrigerator sitting in the garage with my grandmother's. It still works. Now, at the end of life, it used to be that in a lot of towns and townships, they recovered that gas before they did anything to dispose of the refrigerator. But it's not like this is a rampant issue with homes that continually have failures of all these sealed system problems. Eventually, their gases are going to change because there are some targets that are out there, and you're going to see manufacturers have to move to some other things that are probably going to be more expensive to be able to do. And right now, heat pump water heaters are expensive enough, and that's why utility rebates and tax credits that help buy the cost down are so good, because at some point people just say, I'm not going to do it if they get to be too expensive.
Yeah, and speaking of leaking, the question is, decommissioning these systems at the end of their life to avoid that leaking. What kind of processes are there in place for that, or education or training?
Any refrigeration guy can do that, just like for the refrigerator in the house. Most people have one water heater but have 3 refrigerators.
Right.
So if you're going to take that to a landfill or take it someplace, they generally, in lots of towns, there are places that you can go, and a guy goes out there and uses the valve on the refrigerator to evacuate the gas, just like you can on a car. It's probably a bigger concern with automobiles, since more people have cars than have water heaters, to be able to evacuate that system as well and reclaim that gas. It can be done. There's always a fill valve on a water heater. The second service valve is not included on refrigerators or water heaters and hasn't for a number of years because that's a leak point that was eliminated in manufacturing a long time ago.
Mm-hmm. What can you tell us about, obviously there's lots of contractor hesitancy about these things for various reasons, but let's talk about the one both on, the replacement parts, maintenance side, availability of those parts, and then just general availability. I mean, we know, and I'm not going to name any names, we have a client doing a green home now, and their heat pump has been on back order for months. So is it that, how do we, is there anything special going on with this kind of technology, or is it just everything's on back order given the unique situation we're in?
Yeah.
And how can you alleviate people's concerns if they want to buy this or they need someone to fix a part? Are they going to get it, or are they going to be out of luck for a long time?
Every manufacturer that I know of is building. And if you're building, then you got replacement parts. There was a hiccup in the industry a year or so ago where an Indonesian plant and some other suppliers of suppliers had problems, had fires, and unusual global things happened that caused the industry to have a couple of burps along the way. As far as I can see right now, those have been worked out and manufacturers are building and shipping products. The good news about a heat pump water heater is this: it's the only form of heating water in the house that has two methods of doing that. It's got a heat pump that says if anything happens to me, I instantly switch to resistance heat. So the homeowner still has hot water and they're at parity of what they would have had with 50% of American homes electric resistance. If anything happens with the electric resistance, it switches to heat pump. It just means that it's going to take longer to recover, but they still have hot water. So heat pump water heaters did solve one big problem. The emergency service call is rare. It takes something catastrophic happening to knock out the whole water heater. And now the homeowner is like, I got to have this replaced tonight and it's Saturday. What are you going to put in?
Well, Greg, we are at the end of our time. There's still some really good questions, really great technical questions that I'm going to get over to you to help answer. But
Okay.
Where can people go to contact you to learn more about heat pump water heaters, and all that? Yeah, where's a good place?
Bradford White, you could come to gholiday@bradfordwhite.com. That's my email, and my phone number, 502-774-0773. If you go on the web and you go to YouTube and go to the Bradford White page, or if you just type in Greg Holiday heat pump water heater or Aerotherm, what you're going to see is my whole series of videos on sales, where a lot of the things you heard me say today, I will say very brand specifically, but I'll walk you through how a heat pump water heater works. You'll see me walk through that video or that sales tool, because I teach that to contractors all the time, of just how to talk about it. And I'll encourage any of you that are on here, practice on your friends and family this weekend. Just tell them about the technology and just ask them, would you be interested in something like this if it operates like this, this, and this, and saves this much money? And just watch the look on their face when they say, heck yeah, why wouldn't I want something like that? So anybody has any other needs for training, questions, I do these webinars every week, multiple times, depending on, and if I'm not traveling, because I cover the entire country. So reach out to me. I'm happy to help.
Well, thank you so much, Greg, for your time today. Thank you all for joining us. Have a great rest of your week, and we'll catch you next week for our last session of 2022. Take care.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.